the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bordens, and it's Wednesday, August 28th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in Classical Conversations communities. Our club is currently working on a lesson each week as we prepare both ourselves and our children to strategize on how we lead our children through mathematics, and specifically the Math Map. And I'm really excited today because I don't know if she's ever heard me say this before, but I want to tell you quickly a story about Babs, who's going to take over and be an example for us today. The first time I met her, she joined us as early as possible for a Math Map, a learning opportunity, to let us know that she was tired of being excluded from the world of mathematics. And here 5 years later, we've hired her to help lead a whole troop of people interested in mathematics. So whenever I think of you, Babs, I'm just so grateful that you're doing this today. And, we all want to know that we have a purpose on this earth. And quite frankly, you have fulfilled my purpose. I lead a satisfied life because of the joy that you've taken from working on this curriculum. So everybody, Dr. Gilpin and Babs will be leading you today while I go write some more math problems.
Well, she wants me to cry at the beginning of the of the session. That was so nice. Kirsty, did you want to say anything before?
Well, I would just talk about how amazing you are, because you are. And I want to let everybody know that there is no perfect model for the Math Map in community or at home. That the goal of the Math Map was to equip parents to lead math education in their home, which means making it fit your home. And there are just so many resources that we don't expect you to use all of them every week or every year, but to pick and choose the ones that are going to be most helpful to you. And similarly, while we have given tutors recommended in-community outline for working through the curriculum, it's adaptable to each individual community. And so we didn't want you to think that the way I lead something is the only way or the best way or the model way, because it's not. And so we've asked Babs and we're going to have other special guests that come on to give you another way, right? Another perspective, another person who is using the same outline and the same materials, but is going to just be a little bit different so that you understand that the way you do it in community or the way that you do it at home is exactly what God needs you to be doing, that you're not supposed to be like us. Although we may give you some ideas or suggestions or encouragement. And so with that said, I'm going to turn it over to Babs, because after you hear her today, you may want her to be your person every week, because she's just amazing and wonderful. So thanks, Babs.
They're so kind. All right, so this is the biggest Challenge A class I've ever had. It looks like there's 62 of you. So it's pretty exciting and overwhelming at the same time to have this many in my Challenge A class. So we're going to go ahead and get started. So if you do have your booklets, you want to open them up. Our first page we're going to look at, we call it the Math Map, and we've seen this every week. We're just going to see where we are. So we want to make sure we're in the complex domain. Look for that column. We want to look for week 5, multiplication. And so we want to put a check in the box. And I always like to tell my students, okay, how close are we to the end of the semester, right? Weeks 1 through 15. And so we're getting pretty close to the midway point. And so it's good for them to kind of check in and see where they are. So that's really all we want to do on this page. With our kids, obviously there's lots of other things that parents can do and look at, but for our kids, we just want to find our spot. All right, so then we're going to move on to our number knockout. So we have 3 numbers We're going to, we can add, subtract, multiply, divide. We can use powers. We can use square roots or roots of any kind. And so she's going to set the timer. And if you just want to, you can either shout out your equations or you can put them in the chat. And then we'll try to cross them off as we go. All right, timer's up.
5 to the 0 plus 5 to the 0 plus 6 to the 0 equals 3.
Okay.
You can do the same 3 and subtract one of them, and that would be 2. You can do that would be 1. 2 minus 1 is 1.
5 to the
And you-
second power times 6
0.
to the power of 0
Go ahead.
times 5 to the power of 0 is 25.
Good.
6 squared minus 5 is 31 times 5 to the 0 would still be 31. Oh, we did 31 plus. So 6 times 5 is 30 plus 5 to the 0.
Oh, sorry.
Good.
6 to the power of 2 is 36 times 5 to the power of 0 times 5 to the power of 0.
Is
What's the answer? 36.
Good.
5 plus 5 plus 6 is 16.
Good.
5 plus 5 minus 6 is 4.
6 to the power of 2 is 36. Minus 5 to the power of 0 is 35 times 5 to the power of 0 is 35.
Good.
Six plus 5 times 5 to the power of 0 is 11.
Good.
6 plus 5 minus 5 is 6.
Okay, good.
6 to the power of 2 minus 5 to the power of 0 minus 5 to the power of 0 is 34.
Ooh, good. And our time is up. One thing I love is that it looks like somebody, or maybe all of us, were trying to like do one row. And so that's kind of a fun thing, is to see like, can we solve all the numbers in one of the rows? And so I like the way we were doing that. So great job. All right, so we're going to look at our artwork this week, and we're going to try to use a couple of our tools. So one of the tools we have is one of our 5 common topics, storytelling. So I thought this was a good piece of art to start with. Is there somebody who can maybe tell me the story behind what you know about this artwork?
Is it the loaves and fishes?
It is. So what can you tell me about it? Anybody?
So Jesus was teaching a large crowd, and it was dinner time, and they didn't have food. They hadn't planned for that, and so the disciples asked, "What do we do?" And he said, "Go get me whatever you can collect." And he collected, is it 5 loaves and 2 fish? And then Jesus multiplied it to where there was more leftovers than there was from the beginning.
Great. So what's a takeaway from that? What can we learn about Jesus, or about God, about our Father, just from this story?
You can
He's a
multiply.
multiplier.
He is a multiplier. Somebody else, what did you say?
He always has enough.
Exactly. Right.
That he loves us.
Yes. Can you
Like-
think of, oh, go ahead.
You go ahead, Beth.
Can you think of other times or other stories in the Bible or other verses that talk about multiplying?
Israelites,
Say that again.
the Israelites, when they started in Goshen at 70 people, and then there were 2 million.
Ah, good.
In Acts where they added to their numbers.
by 300 or whatever in that one day.
Oh, good.
When you talked about forgiveness, 7 times 70.
Oh, yes.
Creation, where he said, be fruitful and multiply.
Yes. And that's one of our verses. That's part of our cover page. Anything else?
When he told Peter to put the net over on the other side after they'd fished all night and caught nothing.
One of my favorite stories. Yes. Anything else?
And just the go and make more disciples. We are to multiply who we are, more Christians, more disciples.
Yes. I was hoping somebody would pick up on that one because that's one thing that I remember hearing. It was on another call. I remember listening to how this verse about being fruitful and multiply, and then Jesus, telling us to go be fruitful, right? And to make more disciples. It's like the parallel between the Old Testament and the New Testament. All right. Anything else from like a verse from the Bible, a story from the Bible, anything else you see in this artwork that just kind of stands out to you or connects us to our theme of multiplication?
I was thinking about Deuteronomy 1, verse 9 and 10. At that time I said to you, I am not able to bear you by myself. The Lord your God has multiplied you, and behold, you are today as numerous as the stars in heaven.
That's a great verse.
Also, the seed fall on the good ground and multiplied 30-fold, 60-fold.
Yes, great.
Also, there's a child in the picture as well on the bottom right. So it's like that multiplication of generations and this story being passed on, this miracle being passed on to multiple generations.
That's great.
When they talk about the talents, the 3 servants and the talents in the Bible, is it in Matthew where the master gives each of the servants talents and each one is told to do with it what they will, and the one multiplies it a little bit, the other multiplies it a little bit less, and the other doesn't multiply at all?
Yes. You guys have great stories. And this is one common topic I feel like I don't know, maybe I forget to use more. And storytelling it really is easy, right? We're just telling stories. And so this one is an easy one because there already is a story behind it, right? But you could also just take a work of art and say, well, what story could you make up, right? That could go along with that art. And so that's just another way that we can use that common topic. Anything else before we move on? You guys have had some great connections.
Can I ask a question in regards to this topic?
You can surely try, and I'll try to answer it.
Well, I think another friend and we in the ex nihilo week we were talking about where it talks about 1 + 1 + 1. Like that's not necessarily how we see the Holy Spirit or the Trinity or whatever, but that it's more 1 × 1 × 1. And so I've been pondering, why do we see multiplication as a greater, I don't know, that gets us to more than addition? I think that's something that I've been thinking about with, and maybe that's not even true. Maybe that's a place where my math brain needs to be blown a little bit.
I think you need to join Kirsty's master's class in the master's program. That sounds like a great place for that question.
I don't know if anyone had thoughts on it.
We have 20 seconds if anybody wants to join in.
I mean, I think when you were saying that, Nina, I was thinking, like, I think that what's unique in that is the unity. So it's multiplication of unity has a, like, when you're dealing with one functions differently than the other numbers. So
Yeah, that's good. All right, so we're going to move on. We're going to look at our iPages. So this first one, we have our I2 page, and remember, we're going to see this page every single year, right? And so the goal is not that I have to know everything on this page, right? And initially, what I want to do is find things that are familiar to me. And so for you guys, my 69 Challenge A students, what is familiar to you from this page? Is there anything that you've seen before, anything that just kind of stands out to you as maybe I've seen it in another curriculum, maybe I've seen it in another math map booklet? What do you see that's familiar?
So in the red box, I see the letter F, and I believe from the cards, the notation cards, that means frequency.
Somebody needs to mute.
I see a number line with hops on it and another one with vectors on it. We've seen those before.
Great. And it makes a good point. You know, some of us have heard of vectors before. Some of us might not have. But what I can do is look at these two number lines and I can compare them, right? I can say, okay, well, what's in this top number line where I'm working with natural numbers? What's the same in the top number line and the bottom number line?
I was listening with my
Numbers.
kids, the audio note, was it glossary, audio glossary, beta, and it says can read as function of X or F of X.
Okay, so that's something familiar to you guys now from using the glossary.
I see the vectors.
You see, so have you seen vectors before?
Mm-hmm.
Yeah.
Yes, ma'am.
Good. So do you know all about them, or have you had to work with them before, or have you just
I
seen
have
them
had
and
to
maybe they're
work with them a
familiar?
little bit.
Okay, good. Good. So let's look at those two equations, the one above the first number line and the one above the second number line. What do you notice that's the same in both of those equations?
The numbers are the same?
Numbers are the same.
It looks like the operations are the same.
Okay, good.
The order of the numbers is the same.
Yes.
They both use the real numbers.
Okay, good. What's different? What's different about the two equations?
The type of brackets, one's a parentheses and one's a vector bracket. Is that what it's called?
Well, I don't know if well, of course you might could say, but it is a bracket. I don't know if it's called a vector bracket. I've just seen it as a bracket.
I think it's an angle bracket.
Oh, angle bracket. Okay.
I like that the parentheses are round like the hops and the vector brackets are pointy like the vector lines.
Oh, I like that. I like that. All right, so now let's look in the middle. All right. Functions were kind of, I don't know, really unfamiliar to me when I first started the math map. And so I kind of want to look at this together. So if we have three kind of columns, right? We have input numbers, we have some equations, and then we have output numbers, right? And so could I, even if I didn't know anything about functions, could I kind of see what kind of pattern could I see between the input numbers, this equation, and my output numbers? Could I figure out how they went from input to output?
Double.
Okay. So
Yeah,
the
we
numbers on the
see that
left
it's-
are doubling. Yeah, go ahead,
Yeah,
Kelly.
that we're familiar with times two, multiplying times two, double something. So we could see, oh yes, if I put in 1.5 into the equation, the answer would be 3.
Right, exactly. And then at the bottom, we have kind of the same thing. It's a different equation, right? This one is dividing by 2. And so I have another set of numbers. And this time I would probably start with my output numbers because that will kind of help me. That divided by 2 equals my input numbers. But so all I'm doing in this little section is really just looking for the pattern, because I don't really know a lot about functions yet. So I'm going to try to figure out, okay, what is it that I can learn? And so I'm just looking for patterns. And then the bottom, I kind of wanted you to see, so this looks very busy. And I know a lot of parents will look and say, oh, this is too busy for me. We're just going to skip it. But what I want to do is kind of point out one thing. I want to see if you can find all of those inequality or those notations. Like, can you find the less than, the greater than, and then the less than or equal to, and the greater than or equal to? We just look for those, right? Just kind of look in your booklet and see if you can find those. And then if you look for those particular parts of the equation, can we figure out whether when I'm plotting, if they're going to be open or closed? So for example, if we look at that first one, I can pull out X is less than B, right? So if I look for the green lines, they're open. Okay. So let's see. All right. What is that going to tell me? I don't know yet. I got to compare it to something else. If I go to the one all the way on the right, I have A is less than or equal to X, which is less than or equal to B, right? So now when I look at those, when I look at that side, I see that those are colored in plotting points on the line. So what can I determine by looking at those two things? Can anybody help me?
If it includes the number A or the number B, then the circle is closed in. If it does not include it, then it's open.
Good. So if I have a less than or equal to, I should see it closed. But if I just have a less than or greater than, right, it could be open, right? So I'm just looking for what I can determine based on this picture, right? I'm just trying to pull out things that either I can easily grasp or maybe that I already know, right? So good job, guys. You guys already knew a lot of things on this page. So let's move on to I3. All right. So this might seem kind of weird. All right. But I want you to, I think there's two things on this page, at least two things that you as challenge students probably already memorized in foundations. And I want to see if you can tell me what they are.
It's the skip counting.
Yes. Right. So 12 and 9, I'm not going to make anybody sing the song, but I did sing the song in my head when I was preparing for this. So, and so we already know the multiples of 9 and 12, right? Or factors. And so, so that's one thing we already know. Is there anything else you can see on this particular page that maybe you already know or that you've seen before?
The green unity, or on the right middle section, right side where the green boxes are around the identity law.
Yes, I'm so glad you said that, because that's one thing that I thought maybe people would think that's too easy, but I think that's a big thing because we're going to see that all throughout the curriculum. It's in the charts, it's in the lesson pages. So that's a good thing to note. Anything else that looks familiar?
Prime factors are familiar.
Okay.
And the lowest common denominator.
Okay. Unit fraction. Jill likes the unit fraction. So this is a page, the title is Memoria and Arrangement. So a lot of times we get to this page and we're trying to pick out something to memorize. So this kind of, I feel like could be a little tricky because you're like, wow, what could I memorize, right? Well, there are some terms on this page that I think would be a good idea to memorize. Can anybody pick out maybe some acronyms that would be helpful for us to memorize from this page?
LCM and LCD.
Yes, yes. And I think memorizing the unit fraction is good, right? Noticing the green box that they equal 1 would definitely be something to memorize. And then the other title is arrangement, right? So really we're looking at how different these different things are arranged. And so I think this could be like a cheat sheet, right? If I see something in my lesson pages that has to do with prime factorization, I can come back to this cheat sheet and see if that could help me as I'm going through my pages. So again, remembering we're going to see this over and over again, right? You've already pulled out a couple of things you already know or that are familiar, but next year you'll see something new, and the next year you'll see something new. And so that's what we want to do, right? We want to keep doing that. All right, let's go to the next one. All right, our charts. So I'm so glad that Kristen talked about the unity, the green box, because that's also on the charts, right? And so that's something that's familiar to us. So our charts, especially chart 1, has a lot of good terms that we can use, right? If I need to look up a definition for something, there are a lot of those here. And there are a lot that you've already memorized from foundations. Can anybody pick out some of the terms that you memorized in foundations?
Distributive law.
Yes.
Commutative law.
Yes. Anything else you already know or know from foundations?
Associative law, identity law.
Yes. All right, and now let's look at chart 2. So I feel like chart 2 is kind of similar to I2 in the regard of there's a lot of examples on this page. So if I'm working on my lesson pages and I need some help with maybe multiplying natural numbers or multiplying integers, or now, I'm in the complex domain, so I'm going to be multiplying complex numbers, then I can use this as a reference as I'm going through my my lesson pages. And I feel like, I mean, maybe it's just me, but when we used to use Saxon, and like one of my boys would be working through some of the booklets and they would get stuck, I would say, well, go back and read the lesson again, right? But I feel like this is kind of what we do with the charts, what our family does with the charts. If we get stuck, right, we go back and look at the charts and see if there's either an example or a definition or something that can help us. And so it is a good reference for us to look through there. Okay. And again, charts are the same every year. So the more we can, we'll learn a little bit this year. And then what I think will be really cool is to talk to the challenge kids next year when they're in B, when those directors get to say, okay, guys, what's familiar? What have you seen before? And they've already memorized stuff from challenge A, right? And so they're just building that big bank of facts to use as they're working through the lesson pages. All right. Okay, so this is a time where we like to ask our students if there was like an aha moment from last week or something that they kind of struggled with that they wanted to talk through. And so we can share ours as directors. And so I kind of wanted to share something really quick. This was not booklet 4 because my community, we just finished week 2. But this past week, I finally, after 4 years, understood bases. And so that was a big aha moment for me. And I'm not saying I know everything about bases, but I've heard it so many times. And I think I finally figured out, a little bit about base 10 and then how we could convert things from a different base to base 10. And so I was sharing that with my kids this week. And I had 3 parents sitting in, and I think they liked it. Like the kids were like, I don't really know what she's talking about. But really the only reason I shared it was so that they know I'm learning alongside of them. And so as I'm, the more we hear it, all this repetition, we're digging in every year, that the more we can learn. So is there anything from, it doesn't really have to be from
Well,
last
can you
week, but
share
like
with
an
us?
aha moment?
I would love it if you would share with us about the
Me
base
too.
stuff, because I am, that's one of the things I'm getting a little lost on. So if you could just be like, what was your aha about converting bases?
So I don't know if I should be the one, but one of the things was that base 10, there can only be 10 digits. And so there's 0 to 9. And then we compared that to base 2. And base 2, there are only 2 digits. And so they're 0 and 1. And so there's a little cheat sheet in booklet 2 in one of the charts that kind of shows you how to convert those back and forth. And really, I feel like it's like practicing it over and over again before maybe I got it, or maybe I was just finally in a place to listen and attend really well to see the pattern. But I think the biggest thing is that we don't have to know it for booklet for the complex domain. We don't have to know it. And so I guess that's why for the last couple of years I haven't tried to learn it. In booklet 2 in the complex domain, all we're doing is copying. Every week we're just copying this pattern. And so that might be something we can get to maybe at the very end when we have questions, and then we'll have more time to kind of like put stuff on the board and Kirsty can write it on the board. But that is a question I think a lot of us have or have had. And again, we don't have to know it because it's not required for what I need to do. But at some point I just thought, hey, I really need to get this. I really need to figure this out. And so that was kind of my aha moment. But I do think we'll have time because we're going to try to finish up so that we can ask questions at the end. So remind me to come back to that at the end.
I had an aha that also is a based, I guess. Just kind of recognizing different instances where we already use different bases in everyday life, like eggs or inches. Those are base 12, hours and weeks. So those are different things that we know if we go to 8 days, we're into the second week, right? We just automatically think of that. But we look at it on a page and it seems really intimidating to be outside of base 10, but truthfully, like we use it all the time. And so that takes some of that intimidation and mystery out of that different kind of function.
Yeah, good. I'm glad somebody else had an aha moment. Anybody else have
I
something?
had an aha with the base 10 as well. So most of our families in the upper challenge levels are using complex as well for their students. So our directors have been using just the beginning, the picture and sort of the exordium and going into the first couple pages. And one of the teachers, as we were going down for our morning campus connection, she called me in and she said, I can't figure out how to count any further in base 3. And as I looked at it, I'm like, well, you only get 3 digits. So, you have 0, 1, 2, then you have to go back. So your next row would be 1, 0, 1, 1, 1, 2, and then you have to move on. And so we were talking about that with the challenge 3 students, and they were all just looking at it and picking it up and understanding, that that's how the digits in those work. And it was just really cool to see those older students grasping that concept.
That's cool. That's cool.
And
How we all had the same thing. Go ahead,
Yeah,
Becky.
I'm so glad to hear you guys sharing about this because I feel like my ha-ha moment just happened just now because I, like when you go through ex nihilo, you're like, oh, everything's going great. And then you remember it's just the directions. And so when you get into the real work and work 2, I think as a family, I think we completed maybe 3 pages last week. And I was like, I am a failure. I mean, just tailoring aside, like I can only get through 3 pages. That's incredible. But now after what you just said, I was like, we really spent a lot of time like talking through and walking through all the bases. And so I feel like, it's number notation. And that's the other thing. I was like, I'm beating myself up. I'm like, oh my goodness, this is number notation. What am I going to do when we get to equations, So it's good to hear you say, that you really got a good grasp of bases because we didn't finish all those pages, but I feel like my kids understand base now and they're little and I'm a big checker offer. So checker offers of the world reformed here. I think that I just had a big aha moment. So thanks y'all for sharing.
Yay. That's so awesome. That's so awesome. All right. We're going to move on and we will have some time at the end. Okay. So we're going to have time to do the first 2 pages, I think. And so we're going to kind of dive in there. And so we're going to look at the top of page 1. And so the directions say sketch the scalar times the hops, plot the product, begin at origin 0. And so in the math map, we use the scalar first times the hop. And so we have 1 hop that is 1 unit long and it ends at 1. And so we're just drawing the line from our origin to 1. The second one is the reverse 1 interval of 1. And so that's going to be a -1. And so we're gonna, they see it, you see the dotted line going to the first one. Now we're going in the opposite direction. So we're starting at the origin and we're going to -1. Then we have one interval of -1, right? So that's 1 times -1. And so in this one, and you see the answer key is they're starting from the origin and they're going back to -1. And then the reverse one, interval of -1, is where we're starting at the origin and we're going to 1. So we saw the original one, they are using -1, and now we're doing the reverse one integral of -1. And so we're going back to 1. So we're always starting at the origin. And then where we have one hop that is whatever units long. In this case, it's either a +1 or a -1. All right, and then underneath that, same kind of thing, but now we're using different numbers. So we have 3 times 2 is 6. And so we're starting at the origin. And this one is the 3 is the number of hops and 2 is the interval or the length of hops. And so we have 3 hops, each one of there's 2 intervals. And so we're just tracing that example. We are on the real number line. And in that case, we're just using natural numbers. The second one, we get to use a different set of numbers. So now we have negative numbers included there. So we're going to have the real number line, but we're going to have integers this time. And so same thing, we're going to start at 0. This time we're going in the negative direction because we have -2. So I have 3 hops, but I'm going in, I have the -2 interval. So we're using the first one as an example. We're kind of copying that to use for the second. And then on the left-hand side, same kind of thing, but what's a little bit different is now we're using the imaginary set. And so we're going to be up and down, right? We're not going to be using the real number line. So we're looking at the imaginary axis. And so we have 2 hops. And this time we have 3i as our interval. So we start at our origin. And so the first one, we're just tracing, right? And then the second one, we have 2 times a -3i. So we're going to be going down, right, for those 2 hops. And then at the bottom, our number line is the imaginary axis. And we are using, our coefficients are from the integers. All right, so that's the top of that page.
Can I ask a question?
You can.
What on the first on the top right corner, what the dotted line represent?
Well, that's just showing you. So, this one's asking the reverse 1 integral of 1. And so basically we're going in reverse of the regular interval. So reverse is like the negative, right? And so the dotted line is showing where we were. That was the positive interval. And now the reverse is going to be negative. So we're going to make our solid line.
Oh, okay. Thank you.
Mm-hmm. I answered a math question. Yay! All right. Anything else from this page before we move on to page 2? Okay. All right. So the first little section about plotting, I feel like this is very similar to our number line, right? But we are plotting, and this time we're using meters and centimeters. So kind of the same, we kind of say it in the same way. We have 7 meter hops 6 times. And so that would be 42 meters. And so I'm just going to plot it on my ruler and put my little dot close to the 42 meter line. And then I have 700 centimeters 6 times. And so that's 4,200 centimeters. And so I'm going to plot that on the right side. At the bottom, we're talking about standard notation. And so what they've done is they've started with 1.1 times 10 to the first times 10 to the third. And then they convert that into 1.1 times 10 to the fourth. And so I'm going to ask this question and see if anybody can tell me. So I start with 1.1. Does anybody know how I'm going to move my decimal since I'm multiplying by 10 to the fourth?
You move it to the right.
right.
Yes. Yeah. So we're going to the right 4 times. And so I end up with 11,000 centimeters. Good. All right. The top, we have some conversions. This was my kids' least favorite thing to do in math. I remember. So I like that we do have a word problem because there are a lot of people who ask about word problems. So we do have a word problem here. And I'm going to have to get my regular booklet because it's very tiny for me. So the width of the door is a yard and the height of the doorknob from the floor is a meter. Which measurement is shorter? Approximately how much? And compare in inches. So we know we have to do some converting. They've told us that it's going to be in inches. And the good thing is they've already given us the conversion factors, right? And so we really just have to kind of look for the patterns. And so we have our 1 meter is equal to, or 1 meter times 100 centimeters over 1 meter times 1 inch over 2.54 centimeters. And we have to figure out what we're going to do with this. So they've shown us that we can eliminate centimeters, right? They kind of cancel each other out. We can eliminate the meters. They cancel each other out. And so we're left with 100 inches over 2.54. And then I just divide those and my answer is 39.37 inches high. So then I have to do yards, right? Yards into inches. And so I have 1 yard times 3 feet over 1 yard. I have times 12 inches over 1 foot. And I'm eliminating those things so I can cross out yards. I can cross out feet. And so I'm left with 1 times 3 times 12, which is 36. And so I have 36 inches is my width there. And so now I have to decide, okay, they're shorter, which is shorter, or the width of the door is shorter by approximately how much. And so we can kind of estimate that it's about 3 inches shorter. So I like that they already have the conversion chart there for me. So that can kind of help me see, what I'm looking for. And I will tell you, I use the answer key a lot for these kind of problems. So I can see, the pattern, what they did, how they work through that. And I point that to my students as well, so they can use that if their parents allow. Okay, oh, sure.
Question. Do your students in Challenge A recognize the 1 inch equals 2.54 centimeters from foundations? Like, do they see that? Is that something that they recognize from our memory work?
I think a lot of them do. I mean, especially reading it out loud. I think sometimes just seeing it, they might not recognize it, but hearing it, because that was so much part of our memory work, is a good trigger for them. So I do like to read, a lot of these out loud so they can kind of hear that. So that's a good point. That's a good point. Okay, so the bottom has plot the exclusive inequalities or equalities. And so we kind of talked about this on our chart, right? We were looking for, well, actually, I think it was I1, where we were looking for, how to plot and whether it should be open or closed. And so here we notice, again, I'll have to look at mine so I can make it a little bit bigger. We have 2 times 1 is 2, and that's less than A, which is less than 3 times 2, which is 6. So I can circle 2, I can circle 6. Now, am I going to color these in, or am I going to leave them open?
They should be open, right? Because it's exclusive.
Yes, it should be open, right? Because there's no equal, right? So I should have an open 2, an open 6, right? And they're connected. So A could be anywhere in there. All right, then the bottom one, so 3 times -1 is -3, which is less than B, which is less than 3 times 1, which is 3. And so the same thing, I'm going to plot -3, I'm going to plot +3. And is this going to be an open circle or a closed circle?
That should be open too, right? Because it's still exclusive.
That's right. That's right. And so I know that B can be any of those numbers in there, right? So we're still in the real number line. The first number line with natural numbers, and then the bottom number line, we're using integers. All right, we've gotten through first 2 pages. So good job, guys. All right, so let's do our catechism. I'll say the blue and you guys say the orange. So what are the solutions for?
To
check work
and work backward.
Backwards.
Good. What is the inside back cover for?
To extend the conversation and fill the lesson 29 booklet.
You guys are really good at this, much better than some of my kids. What is the back cover for?
To
play games.
What is the careful calculations page for?
As a review or
test.
What are the flashcards for?
So I can read math.
What is the Math Map companion for?
So my parents can answer my
questions.
And what are the lesson pages for?
To practice math
concepts.
Yay, good job. Good job.
All right, what is it?
Oh, all the arrows.
Oh, I just realized what was happening. Thanks, Babs. You were amazing and inspiring as always, and I so appreciate you. And I know everybody else did. Just reminding you all of your support resources. Next week, we will be looking at division, then exponentiation, equations, and straight lines to round out September. And notice that at the end of September, lesson 9 will actually be moving into 2D. So we're going to be working through 1D for most of September in our arithmetic and algebra there. All right, so we have been working on finishing up a little bit earlier to maximize question time. And so the floor is open. I am gonna, but while you guys are thinking about your questions, you can either put those in the chat or you can raise your hand and we'll answer those. The question of base, I'm gonna go ahead and just step through it really quickly the way that I have for others. That when we think about our bases, our numbers, right? So just looking here, these could go on and on. Every place has a value, right? That our number system has a value. And so it's based on the value of that place is based on our base. So when we're talking about base 10, I have the 0th power of 10, the first power of 10, the second power of 10, and so on. Going the other way, my indices are negative and so on. So the value, right? So that's how I can express it using powers, but I could also write the value that this is 1, 10, 100, right? 100, that's my hundreds place. There you go. This is 1/10. And so when I put a number in, I'm going to change my pen color here, if it will let me. All right. If I had a number like 473.2, what I'm saying is that I have 4 hundreds, 7 tens, 3 ones, and 2 1/10. And that gives me my number that I've expressed. And I apologize for that. I'm going to try I'm going to try using the whiteboard here, see if it's any better. All right. Hopefully everybody can see the whiteboard. Okay. So really quickly, we had our base, our powers of the base. And that would keep going, That's the pattern. So that's 100, 10, 1, 1/10, and so on. And I know I'm using different numbers because I can't remember what I had before. But I have 7 times 100 plus 4 times 10 plus 3 times 1 plus 2 times 1/10. So this is my base 10. Those are the numbers that we're really familiar with. If we use a different base, we set it up the same way. So let's say base 3. So now, if I look at just these same 4 places, the power that I'm interested in is the same, right? So the same index, but now I'm going to say that my base is 3 instead of 10. And we'll talk in a minute how we count in those bases. So let's just put some numbers in here that we're going to use. What this is telling me now is that this is 3 times 2 of 3 squared, which in base 10 is 9. So this would be 2 times 9. This would be 1 of the first power of 3, which in base 10 is just 3. So 1 times 3. This is 1. So I have 1, 1. And this is 1/3. And so this is 2 times 1/3. And if I was to write these, this is now essentially how I convert to base 10. So 311.2 in base 3 is the same thing as 18 plus 3 plus 1. So that'd be 22 and 2/3. So 211.2 in base 3 is the same thing as 22 and 2/3 in base 10. So that's how I'm doing that conversion. But what we're seeing, that pattern there, is that I can use any base in order to establish what the value of those places are.
Can I ask a question?
Yep.
Okay. So this is really helpful. I think what would help me kind of close the gap is if you use the same number. So at the top you have 743.2. Can you do that in base 3 where instead of writing 211.2 at the top, you would write 743.2 at the
So
top?
here's why I cannot do that. So let's see if I can figure out how to oh wait, look, I'm going to move this over and I'm going to show you how we count. All right. So in base 10, right? Nope, 10. There we go. In base 10, I count 0, 1 1, 2 1s, 3 1s, 4 1s, 5 1s, 6 1s, 7 1s, 8 1s, 9 1s. And then if I add one more, I get 10, which is 1 10 and 0 1s. And I add one more and I have 1 10 and 1 1. And we're familiar with that pattern. But this is what happens if I'm in base 3. So let's just review. So base 3, right? I had 1s. I had 3s. I had 9s. And if I kept going, my next one would be 27s. So 0 is still 0. 1 is still 1. 2 is still 2. But now I hit 3. I can't say I have 3 1s. I have to say I have 1 3 and 0 1s. And then if I add 1, I have 1 3 and 1 1. And then I have 1 3 and 2 1s. Now I add 1. In base 10, it's 6. But really what I'm doing is base 2. I now have 2 3s. Oops, sorry. 2 3s and 0 1s. Adding 1, I have 2 3s and 1 1. Then I have 2 3s and 2 1s, but now I add one more, and I would now have another 3. So I would have to move that over to my 3s column, right? So I would have 0 1s, and now I would have one more 3, but 3 3s is the same as 9. So I would actually have 1 9, 0 3s, and 0 1. Then adding 1, I would have a 9, no 3s, and a 1, and so forth. A 9, no 3s, and 2 1s. And then if I was to keep going, let me see if I can move this over a little bit.
Why does the 1 represent 9 now instead of representing the 3 that it represented before?
So because it's the position, right? So this place, this position is 1s. This position, right, that's this one, is 3s. And then the next position over is this one, and that's my 9s. So if I have 3 3s, that's the same as 1 9. So that's why I have to
So
bump
could it
over.
have been 3 3 0 or no?
No, I can't, right? Just like when I go to write 10, what happens? Like it becomes 1 10 and 0 1s. So it has to follow the same thing here. I can't force 3 3s into that spot.
Because the notation of the number 3 doesn't exist in the 3 base. It's just 0 1 and 2.
It's just 0 1 and 2.
Okay.
So that's why I couldn't do the same digits, because those digits I used for base 10 weren't accessible to me when I'm in base 2 or base 3 or 4, right? Depending on the base I'm in. That's why. And that's why, so if you went the other way, right, and you look at base 16, so anybody that's into computers and you look at hex, that's base 16, right? In base 16, this is my 1s. Then my next place is worth 16, right? So I need to have 16 digits to represent what in base 10 would be 0 through 15. So I use 0 through 9, and then I have to use letters. I use A, B, C, D, E, I think an F. 6, right? 16, yes. So because I can't say, oh, well, there's 10 here, because we're in this positional system, right? So as soon as I see 2 digits, they each have a value. So that's where here I would use A, right? So A in base 16 is the same thing as saying 10 in base 10, right? So going the other way, I have to have more letters. I use letters because I need more digits.
So is that why there's those hexadecimal color codes where there's the letters and the numbers all together for the hex codes for color theory?
Yes.
My daughter's in color theory starting yesterday. So
and that's exactly it. So if you saw like a 4H3F, right? And see, I don't have them memorized. So this would be like 10, 11, 12, 13, 14, 15. So this would be 4 times 16 cubed plus H. Maybe I don't need H. Maybe let's say E, right? Sorry. E. So that would be 14 times 16 squared plus 3 times 16 plus 15 times the 0th power, or 1, right? And so that's how I would convert from this hex code to a decimal number. And so it means that it's taking up in our computer memories a lot less space, right? And that's why they use hex code, because it's all about, right? I can say in fewer digits the same thing that it would take me to say in more digits.
Okay, I have one more question. I think, like I said, we'll close the gap. You remember on the other screen when you had like 700 and something at the top in base 10?
Yep.
Can you help me know why you can't convert that to base 3?
I can convert it to base 3. Converting it to base 3 is more work than converting from another base to base 10. And so I can circle back to that. But basically what I have to do is divide and say, well, how many of each power of 3 do I have, right? So if I
You
was
just have
to
to do
look,
it in the reverse order.
yes, it just is more work. And so I'll end up with a longer number, right? So that's why if you think, like we look here, right? Yeah. Right. So here's an example of that. Right. 11 in base 10 is 2 digits. That same value is 3 digits in base 3. So as those numbers get bigger, right, those numbers just get longer, right, to express what they're worth.
Okay. Excuse me. Okay, and do you, when you're using base 3 or base 2 or whatever other base, do you still just write it out with no commas or decimals or anything else, just like we would with base 10?
The only one, so sometimes people will leave a space. The only one that I have found that has an actual sort of rules around the spaces is base 2. And again, that comes from the idea of computer language, but in base 2, they usually will break it sometimes sometimes a small break between the sets of 4, but a bigger break between, if I was to write this out, a bigger break between groups of 8. And that's where in computer language, each digit is called a bit. Each group of 8 is called a byte. So if you think about your terabyte, right, those are the bytes that they're talking about, are groups of 8, because your machine language in your computer is all zeros and ones, because it basically means that it's either on or off, right? So I can do that with electricity. I can either say this bit is on, which is a 1, or it's off, which is a 0. And so that's how your machine language in your computer works. And so people used to, right, program in that, and now we don't need to program in that. But that's the very basic underlying concept of how your computer stores data, is in zeros and ones. And so when we say that there's a terabyte, we're saying that that's how many like places that you can have your data turned on and off in your memory.
Wow.
All right, so that was looking at bases, and it was kind of a quick thing, but are there other questions that you guys have? I'm looking to see. Veronica, you have your hand raised.
Hi, thank you. It is a base question, but it relates to the curriculum, I guess. And when I watch you laying it out, counting in 10, and then showing me what it looks like to count in base 3, that visual is super helpful to me. Like I finally feel like, oh, I'm seeing maybe the very edge of the tip of the iceberg with the bases. Is there a place already in a different level of the math map, or will there be one in a future level of the math map that will lay it out for us and our students like that, to kind of give us that visual help of here's the base, you recognize base 10, and then here's what it looks like to count it out in 2 and 3?
So I do have it. If you go into the companion and you go to booklet 2 to chart 3, and you look at the chart, and there's that piece in the chart that looks like the iPage there, where we have the different bases with all their place values. If you click on that, on the right hand side, I actually do have a parallel there of base 10 and base 2. So there is an example there that's accessible right now. It's not a video, it's written out with words versus a video. And over time, I will add more, but right now, I am the sole creator of content for the companion, and so I can only get so much done in a week.
Right.
So,
So
but
there's
that-
something in the companion, but there's nothing in any of the booklets that would lay it out that way?
Well, I mean, and that's where Lee, and that we acknowledge that it was not necessarily written well, but she does have in booklet 2, those exercises that are on the 3 set. And the first one actually has you with, like 0, 0, 0, 1, 0, 2, I forget what base it is. And you see it, and then you're just filling in the 2 blanks. And I think that's on page 3 or 7, and then 11 and 15, it's just all blanks, which we've acknowledged is not well done. But that's where, and each year there's going to be a similar exercise there, so that students are going to be seeing that pattern of counting through those first few digits to help them do that.
Okay. Thank you.
Can I just suggest that you take the segment that you just did on this video and pop it into the companion? I think that would be really helpful.
All right, Babs is my brain for things like that. So we'll let Babs
Already
remember.
wrote it down, ma'am.
All right, Angela, I see your hand raised.
Thank you for taking my question. These have been so helpful, and I'm just so grateful. My question I actually have for Babs. Back in April, our Des Moines, Iowa community was able to attend one of Lee Borton's Math Map events. And something she said was extremely encouraging to me, how decades ago, the government schools targeted the 20% of people who could understand math. And I definitely fall into the 80% who was not targeted for math curriculums. So this math map is like really new, but I'm really excited about it to hopefully, kind of like Babs shared, she wanted to not be in the or she wanted to, understand math. So that was super encouraging to me to hear her just kind of her personal story on that. My question is, just from an encouragement perspective, Babs, how long did it take you? I think you said you've been with Math Map for 5 years. Is that correct? How long did it take you before you really started understanding and seeing the bigger picture of how the Math Map works? We have been with CC for long enough for me to understand and to truly trust the process. And I've seen that happen with the Essentials program. And so it's been super helpful. So I do trust that it works. And we are just going to do the grammar and get little bits at a time when we can. But how long was it before you really started feeling like you were redeeming your math education?
So this might sound silly, but the very first meeting I had, I did, because I actually said, I don't think I should be here. This is not the place for me, because I'm not, I don't have an extensive math background. And so that very first week that I started learning, I learned more than I probably learned in all of my years of school. And so I think the thing is the willingness to want to learn it. Right. And and when I was in school, I didn't have the desire to want to learn it. But now that I'm an adult, I was yearning for it. And so, and I didn't want to be one of those people who just said, well, I can't do math. Like, I don't want to say that. And so even that very first year, I felt like I had learned so much, and I feel like I still don't know everything. Like, there's so much I still don't know. But I feel like even every week, even as I was preparing for this morning, I learned something else. And so every time I get the booklets out, I feel like I always learn something. And I guess it depends on your background. Maybe you already know a lot that I don't know, but I feel like to me, it was immediate. Like, I learned the very first week that I started working through the math map I learned. So
that's really helpful. Thank you so much. To both you and Dr. Kirsty.
All right.
Kirsty, I have a quick comment
Sure.
that some people may or may not know about. So we do in Challenge B, we do a full year of logic. And in the intermediate logic book, we don't cover it, but there is a whole section on digital logic with the zeros and the ones and learning base 2 in that. And so if your student is very interested in that and you are going to be in intermediate logic and challenge B, that may be a resource to use. It's not part of our curriculum for CC, but actually both of my kids went through it on their own over the summer. So that can help them understand a different base.
Great. And as Babs pointed out earlier, remember, you don't have to understand bases this year. You don't have to understand all of the bases this year. The thing that we do want people to understand is the place value, and that every digit in our numbers that we use every day, that depending on where that 3 is, right? So if I wrote, let me get this pen back, right? If I wrote this number, I have 4 3s. Well, let's make it 5 3s. But each of those 3s has a different value based on where it is in the number, right? And I think that we all understand that intrinsically, right? Because we've been using these. So when I say us, I'm meaning us as parents, right? We all go, that's 3,000, that's 300, that's 30, that's 3, and that's 3/10. And that's the big idea that we want our students to get. We're putting the grammar to that in saying, well, why is that 1? Well, it's because whatever my base is, in this case, base 10, it's the 0th power. And there's this pattern where I could keep going, right? Even if I didn't know the names of those numbers, I could keep this pattern going infinitely left and infinitely right. And I can tell you what the value of any of those places is. And so that's the big idea. And I think most of you all get that idea, right? Because you would all sit there and go, well, that's 3,333.3. And so that's our big idea. We're putting grammar to it by telling them, hey, write it this way, the 0th power, the 1st power, and so on. But that might not, right? That grammar may not make those connections until next year or the year after, right? We may have to play with this for a while. But I just want to pull us all back and go, remember, the big idea is place value. The bases just give us a way of communicating that. Nina or Nina, I'm sorry if I'm mispronouncing your name. No, if you're in the companion, when you're open up the companion and you see that that left-hand page, which is the math map, you're going to want to click on the complex column booklet 2. And then if you can either flip through all the pages, but if you use the little hamburger menu on the right-hand side and you click on that, you want to go down to chart 3. And then that'll open up and you'll see chart 3 on the left-hand side of your page. And in the middle, that middle block, you can click on that and get more information on the right-hand side. If you need help with that, if you email Babs and Shauna, they'll be able to send you a screenshot and help you better navigate that. So. All right, any other last minute questions? Because I really appreciate that you guys come every week and that you're asking these questions and you're diving deep, and we really want to provide that opportunity for you. So thank you for bringing your questions. Thank you, Babs, for inspiring us all today. And Babs has been it's been really, I've grown. When you guys go, we're not math people. I would have been told I was a math person, right, from a fairly young age. But I have grown so much in the writing of this, and I have learned so much, right? So I was a math teacher. I was a high school math teacher. I have, right, master's degrees and so forth. But working through the math map and looking at math dimensionally and looking at it the way we're looking at it in the math map, I have learned so much. So I just want to really encourage you, wherever you are on your math journey, we're all still learning. There is nobody out there in the world that knows all there is to know about math, except God, right? God, obviously, but like human beings, there is nobody who knows all there is to know about math. So we're all on that journey of learning and discovering. Kristen, did you have a last question? Did I see your hand? Okay. All right. Well, thank you, everybody. Have a great week, and we'll meet you next week for division, everybody's favorite operation.